This is Thomas Asbell speaking for Seth McCann's problem. This is question 4 of the 2008 test. The question says, a particle moves along the x-axis so that its velocity at time t for 0 is less than or equal to t is less than or equal to 6 is given by a differentiable function v whose graph is shown above. The velocity is 0 at t equals 0, t equals 3, and t equals 5. And the graph has horizontal tangents at t equals 1 and t equals 4. The areas of the regions bounded by the t-axis and the graph of v on the intervals 0 to 3, 3 to 5, and 5 to 6 are 8, 3, and 2 respectively. At time t equals 0, the particle is at x equals negative 2. Part A of this question asks, for 0 is less than or equal to t is less than or equal to 6, find both the time and position of the particle when the particle is farthest to the left, then justify your answer. To start with this question, you need to consider the question's initial condition, which is at t equals 0, the particle is at x equals negative 2. Next, you need to look at the critical points, which are t equals 3, t equals 5, and the endpoint t equals 6. Since t equals 5 has the particle moving to the right, and we are trying to find where the particle is farthest to the left, t equals 5 is eliminated. So the 2 points to consider are t equals 3 and t equals 6. First, set up an integral to consider t equals 3. Negative 2 plus the integral from 0 to 3, v of t, equals negative 10. Next, set up an integral to consider the endpoint t equals 6. Negative 2 plus the integral from 0 to 6, v of t, equals negative 9. Since negative 9 is greater than negative 10, this means that at t equals 3, the particle is farthest to the left at position negative 10. This question is worth 3 points. The first point comes from identifying t equals 3 as a candidate. Next, you need to consider the integral from 0 to 6 v of t dt. Lastly, you need to find a conclusion, and that's your answer. Question B asks, for how many values of t where 0 is less than or equal to t is less than or equal to 6 is the particle at x equals negative 8, then explain your reasoning. Since the initial condition is negative 2 at t equals 0, subtracting the area of 8 below the t-axis means that v of 3 equals negative 10. By the intermediate value theorem, this means that the graph had to have crossed the point x equals negative 8. The same theory applies from t equals 3 to t equals 5, which equals negative 7, and t equals 5 to t equals 6, which equals negative 9. This means that by the intermediate value theorem, there are 3 times at which the particle is at x equals negative 8. This question is worth 3 points. The first point comes from finding the positions at t equals 3, t equals 5, and t equals 6. The second point is a description of the motion of the particle, and the third point is your conclusion for this question. Part C of this question asks, on the interval 2 is less than t is less than 3, is the speed of the particle increasing or decreasing, and give a reason for your answer. Speed is given by the absolute value of velocity. Even though the graph above showing velocity is negative from 2 is less than t is less than 3, the absolute value is always positive. The speed is decreasing on this interval because the absolute value is decreasing. This question is worth 1 point. The 1 point comes from answering the question with correct and proper reasoning. Question D asks, during what time intervals, if any, is the acceleration of the particle negative? Justify your answer. Since the graph shows velocity and question D asks for when the acceleration, the derivative of velocity, is negative, we can find the graph of velocity is literally decreasing. This occurs on the intervals from 0 is less than t is less than 1, and the interval from 4 is less than t is less than 6. This question is worth 2 points. The first is coming up with an answer, and the second, a justification for your answer.